So we call panel data also as longitudinal data or cross-sectional time series data. And I said that this one involves observing multiple entities. By entities, I'm talking of things like individuals, companies, countries over multiple time periods. So this one combines time series and cross-sectional data, giving it a unique advantages and requiring specific analytical techniques. So we have different features of data, panel data. We have the cross-sectional dimension, we have the time series dimension, and for panel data, we have two types, the balanced panel and the unbalanced panel. We are going to see that when we are working on the dataset. Balanced panel is when each entity or each observation, let's say we are working with countries, it has observations for all time periods. For example, if you have 100 farms that are talking about observations for 10 years, each will have 10 years. Then we have each farm, like the first one should have up from 1 to 10, the second one 1 to 10, etc. Then for unbalanced panel is when some entities have missing observations for a certain period of time. So the advantage of using panel data is that you are able to capture heterogeneity among entities and you are able to control for unobserved effects, talk of fixed or random effects. So it's going to allow for dynamic adjustments and tracking of changes over time. So the first step when working with panel data, I don't know if you already have the data set.
Yes.
Yeah. So after
Yeah.
downloading, you can choose to import, or I said you can just select from Excel, click on this, select all to copy, and then in your starter, go to this and paste. I've already pasted mine.
Is it only myself that is not seeing your screen, or you're actually not projecting?
Oh, I was actually not presenting. Wow.
Oh, okay. Sorry.
So I said after downloading the dataset, you can open in Excel file, then select all, and then copy, or you can import directly from the starter menu. So if you want to copy in starter, ensure that you what do we say? You use the edit window. So for this one, let me close off this one first. So if you want to use you want to paste, you can just type in edit after copying your data, and then you paste. Allow your first row on the clipboard to read as your variable names. Then okay. Now you still have the same data set. Or you can choose to work with the import option. I think this one is a CSV. So you import, then select CSV. So the first step when you're working with panel data is you need to have a time dimension. Time dimension is an important feature when you are working with panel data, because you are going to perform um, data structure to see if your panel is balanced or not balanced. So to start, let me do that again. Panel data. Panel data, I said that this data that is going to combine cross-sectional and time series dimensions. So if you are going to observe multiple entities, you are going to do it over multiple periods of years. So the reason why we perform a panel data is if we want to control for country specific characteristics. Let's say if we have country variable or institutions or geography, and if you want to focus on the relationship between policy variables and economic performance. So let me type here the definition again. Panel data. I should use slashes to show that it's a command. So I said that panel data combines cross-sectional and time series. For cross-sectional data, this one is basically data or observations on multiple entities. And I'm talking of things like countries, firms, or individuals. Then if you're talking about time series data, this one are just repeated observations over time. For example, we can have maybe how countries were behaving in terms of sales for a particular period of time. For example, for this data set, I think it must be from 2010 to 2025. So we could still use the normal way or the pooled regression, but then for pooled regression, we do it if each observation is independent. But now when we use that with panel data, it means that we're going to omit variable bias, and then we'll have some dynamic changes might miss. So the reason why panel data helps is because we are able to use the panel models. And for the panel models, we have things like FE and the RE. The FE is the fixed effect model, and then the RE is the random. So this one is the random effects model, and then this one is the fixed effects model. What is it called? Yeah, the fixed effects model. So for fixed effect, one controls for all time invariant country characteristics. Then it reduces bias from unobserved heterogeneity. But for random, this one is more as efficient if you are holding on assumption. So I think when I explain like that, I don't know. Okay, let me use an example. For example, if you're working with a fixed effect model, then use an example like in our data set. Let me use something like unemployment rate. So if unemployment rate in Angola increases by 1%, and that is in comparison to Angola's on average, then the question of the day will be how does Angola's GDP growth change? Then if you're working with a random effect, then we are working with an example like on average across all countries. How does higher unemployment compare to lower unemployment while explaining the GDP growth? So we will do that using an example, and I think you'll be able to understand. So the first thing while working with panel data is you need to set your panel data. You need to set your panel data, and that is in data preparation. So for that, we are going to use the xtset command. I'm going to perform all that. For in preparation, you can use the xtset command. So for xtset, it's used to tell your Stata that your dataset has repeated measures for the same entities, and our entities in this case is a country. Our entities in this case, we are talking about country, because we have different countries. And after now performing the data preparation, after setting our panel data, the second step is on summary statistics. Like you need to understand how your data is in terms of the means, the variations, and the correlations. So you need to understand if your data is varying across countries or within countries. So you will perform a summary stat. Then after that, you can visualize. So it's just like the other one, but then for this, we are working with different time dimensions. So that's the reason why we are using the. You have to use the panel data. Then afterwards, you can perform a simple or the common regression that we did using the regress or sometimes the reg only. Then after that, now we'll choose the FE. We have different types of models. We have the FE, and then we have the RE. We have, is it the mixed effects model or linear something? I've forgotten the name. Then now after doing that, but for this case, you're only going to use the fixed effect and the random effect. So after that, now you'll conduct something we call a Hussman test to determine between the two, between the FA and the RE, which one are you going to work with? Because they're both going to give you the same results, only with a few changes maybe. Then after that, now is when you can add even ear effect to control for global shocks. So let's start. So the first thing, let me go to my starter window. So the first thing you have to do, I said, is to prep your data. You need to tell Stata that you are working with panel data. And to do that, I said use the xtset command, then followed by your variables. So mostly we have a panel variable. You need to start with a panel variable. This one is a variable that is going to identify your entities. So in this case, something that can identify our entities is maybe something like country. I think we have country ID. So let me just select here the variables to see them here. We have country ID, so I can use country ID to work as my panel variable to identify my entities. My entities in this case is country, so I can work with country ID. Then I have to use a time variable. You start with a panel variable, then a time variable, the one that is going to show you your ears. And now in my ears, I can see that I have ear. To confirm that, you can go back to your edit and familiarize yourself with all these ears. So after doing that, you just hit enter. But then looking at our data set, the country ID, let's just go back and trace the country ID. You can see that it is something like a string, but now you can't work with strings here. You need to change to numerics. So that's when you'll use you remember when we used yesterday the toString and the dstring? You can also use another one called the encode. So in this case, um, I'm going to, or you can even, so to confirm that if you don't want to go back to the edit, you can just click on country ID, and then here you can see that our type is a string, or you can choose to have a look at it by describing. You can describe your data, and then you will get to see you if it's a string or if it's numeric. So first, let me use also the describe option. So you can just describe country ID, and now you will see that the storage type is a string. So to convert to a numeric, we can use the encode. Yesterday we used the toString and the dstring to change them, but now let's use the encode. So you can encode country ID, and then now you generate a new variable. So for generate, you can either type the full name generate or just gen. Then now how we want to name the variable that we want to use. So I can call it something like a country, but now in number instead of having ID. And then after that, I will hit enter. So now you can notice that we have another variable called country num. But now if you see, it's in long. As much as it's going to display as a string, still it's going to work as a, it will work here. Because you see now it's still working the same. We have the AW just like we did here. Remember, when we started, I told you that string variables are usually in color red, and I hope you can see that. But once you convert to numeric, they will convert to color blue. So now after doing that, so the encode here, the encode assigns a unique numeric code to each string. You can also use the whatever. So for example, in this case, we can go further and specify, though I'm not going to do that, where we can say that we can add value labels, where you can say that maybe AW is 1, whatever is 2, but then we have so many countries. So I'm not going to do that. We are going to work with it as it is. So now after doing that, you declare your panel data again. So because I already have it, I'll just click here to have here, but now I can't work with the country ID. Remember, because I've converted to string and I mean to numeric, and I've given it a new name, I'll have to use that name. So in this case, I'm going to use the command xtset, then a country that I've converted to string, then followed by my time variable, and then hit enter. So Stata now accepts and tells us whether our panel is balanced or unbalanced. Remember I said the XT needs numeric IDs for efficiency and for panel specific commands like the XT-reg that you're going to perform, the XT-line, etc. So keeping a string country codes like the ones that we had before, it can work if and only if you've already modeled it into a numeric mapping. So now after doing that, you can confirm, you can just xt, or you can describe the command. I'm not going to do that. So after setting the panel structure, it tells us if our panel variable is strongly balanced or if it's not strongly balanced. Remember I said that for strongly balanced or not balanced is when you are talking about something like each entity or observation having all time periods. Now to confirm that, maybe I can just go back to my editor, and then you can see that we have like the first country name is Andorra, and then we can see that it has different time points from 2010 to 2025, and then the next one is United Arab Emirates, and then you can see that. So for it to be balanced, it means that each entity has observations for all time periods. And then if it's unbalanced, meaning that some entities have missing observations for time periods. So maybe if it was unbalanced, I'll have maybe a country like maybe Armenia having like from 2010 to 2015, and then the other years are missing. But because here I have all the entries, that means that it's going to return balanced. So this one is a perfect one when you want to do the when you want to work with the panel data. Now, after setting the panel data is when now you start the descriptive analysis. So for descriptive analysis, yes.
Thank you, Miss Eugenia. Supposing it was not balanced,
Mhm.
does Stata actually highlight which country probably does not have all the years, or you'd have to? It's a pointer for you to go and look through your data.
If you perform further analysis, you will see it.
So when you run that XT set, it's like an indication before you go ahead to perform that further analysis, right?
Yes, that one you're just using it to set to show Stata that you're working with a panel data.
Okay, thank you.
Then so if it's unbalanced, how can I put it? Shall I edit some entries to show you that? If it's unbalanced, you're going to get like a minimum 10 points per entity, or you're going to get the number of gaps that you have. So to see where the panel data is having the unbalanced data, you will type in the command uh, maybe because it's going to highlight. So you are going to maybe say by a specific farm that you have. Let's name it maybe by school. Then now generates the observations is equals to. Then you'll put an underscore to show that you want it to generate the observations from this point to this point. Then now you will hit enter, and it's going to display, or it's going to show you how many periods each farm has. If it's a country, if it's wherever, so it's going to show you that. So you can, after that, you can also tabulate to make it easier for you to notice where you have missing periods. So now for descriptive statistics, I said you use the XT. So for the other one, without having the panel data, we were just typing in direct things like describe or set etc. But now because it's a panel data, we start by XT. So here you can just type in XT describe, and then you are going to get the total number of countries. You're going to get the time span and balance of the panel. So for example, here you can see that we have 217 unique entities, 1 to 217. Then our year is running from 2010 to 2025. So because it's a balanced panel, it means that every country that we are working with has data points for all the, is it 16 years? Yeah, for all the 16 years. So it means that no missing years for any country. Remember, I'm talking about years. We're not talking about the other entities. I mean the other columns, because for you can have something like inflation where you will notice that you have missing values. That's why in our analysis you're going to realize that we are not going to have, if let's say I'm working with I want to see the GDP of a particular country, but then I want to look at also inflation, you're going to notice that numbers are going to be a bit different. But because I'm working with years and it's showing me that it's balanced, then that means that every country has data for all 16 years, no missing years for any country. So these are perfect structure for panel data analysis. So now you can run our XT models without structural issues. So here we can see that we have 217 total country numbers, and then each country, yeah. So after that, now we'll go to basic summary statistics. So for basic summary statistics, remember, if you are working normally, we'll just type in something like sum or summarize. But because it's a panel data, you can just type in xt sum or xt summarize. Then we can have something like inflation. So instead of typing, I'm just going to double click on it from the variable box. Then I can also have a look at this one. Maybe we can look at public debt, and then we can also have a look at the interest. We can have a look at the interest rate also. So if I want to get a basic summary for all these, I'll just hit xt sum, then followed by my variables, just like the other one, then hit enter. And I'm going to get the overall mean between the countries variation and within the country variation. So this one helps you to see which variables vary mostly across countries over time within each entity. So we have the between. I think this one is more direct also because it's just like the other one. Because now, for example, for this one, you can see that average inflation for all countries and years was 6.63, and then for the standard deviation etc. Then for the GDP, you can also see for public. So it's more direct. This one is just used to show you the overall. And for this one, you can see that it's 2.8. So that means average growth across all countries and years had a mean of 2.85 etc. Then the next thing is so the reason why these stats matter before modeling is because we need to understand the between and within variation. We need to understand the between and the within variation. So for example, for the first one, where we had negative 54, I'm talking about this one. The overall mean in this case was 2.8. That is the average growth across all countries and years. Then between the standard deviation, we can see that it was 2.37. Countries differ moderately in long-term growth averages. Then we have the within. The within talks about, so for between, it talks about the countries differing moderately in long term. Then the within, countries experiencing year-to-year volatility. Then for the minimum and the maximum, I think it's direct. So from this, you can see that the GDP growth has strong short-term fluctuations. So I was talking of this. Remember when I was talking of having different ends and n? So these ones are just like the total observations over time within that period, the 16 years and the number of observations that you have. The N is the number of countries. So different sample size. These are just like different sample sizes, and they are used to tell us some variables. For example, the interest rate and um, public debt. We can see that they have missing data. So consider how missing values might bias results or require imputation. And for imputation, we talked of other methods. So the next step after doing this is to run correlation. For correlation, remember we can work with pairwise, PW, pairwise correlation, where we can still work with the interest rate fluctuation. We can work with the GDP, and we can also work with the public and even the interest rate. Let me also add inflation. So it's just like the other one. Then now you can hit your enter. So you are going to get the results. Remember I said correlation between a variable and itself is usually going to be 1 because a variable is perfectly correlated to itself. So for I think for that you can interpret. Remember we talked of -1 to 1 where we talked of the weak, the moderate, and the moderate, and the perfectly correlated ones. Then after that, if you want to have a look at your unique country names, because we have different country names. We have like 217. It's a large data set. So if maybe we don't want to scroll down to have a look at the names that you have, and you still want to have a look at all the names that you have, you can just type in the command levels of, then now type in your country name. Remember, I don't have a space here because if you put a space, it's going to read it as another command. So you are mostly going to return an error of. Let me do that. You are going to return an error of f is not. Yeah, f is not found in this. So just type without having the f levels of, then hit enter. So after hitting enter, you are going to get all the countries, all the unique names of the countries that you have, all the 257. And I'm doing this because let's say I want to perform a visual. Let's say I want to see a line trend of how the cells have been behaving in these different countries. That means I'm going to have a line that is kind of not good looking. For example, let me just type that to show you that. So for a line, I'm just going to type xt line, like the normal one, and then I can have let me display the let me see which variable to work with first. I can choose to work with the GDP annual. Uh, yeah. So you can either type or you can use the option that I showed you. So let me type that first. It's a bit slow. So you can either work with that, or if you want to add an overlay, you can also add an overlay in case you want to see the patterns over time for all the countries, how they were behaving. Mine is taking time. I don't know if yours has already executed. I'm supposed to have a comma here. Mm, for overlay. I don't know if it's my Stata that is hanging, because I can't even see the output at this point.
Eugenia,
Pardon?
sorry, Winnie, you were saying something.
No, I just said I'm also not getting any output.
You're also
I
not
have
getting any.
I've got an output, but it's like I have a million tiny graphs.
Yeah, because now remember you are displaying 217,
Yeah.
217 countries.
Mm.
Yeah. So I don't know what's happening on my line graph, also for Winnie's.
Still my output. Oh, finally, I got
Finally.
it.
Wow,
Mm.
lucky you. I'm still waiting for mine. So, but if you've still got it, we can continue as we give it time. So, for that, it's going to be hard for you to interpret or to see if, let's say, you want to look at Lebanon or Madagascar, or even you want to look at Uganda to be specific. It's going to be hard for you to notice the trends. So, that's why we used these just to have a look at our countries, the levels of country name, just to have a look at all our countries, just in case we want to work with any. So for that, you're going to type in the command, just a minute. So if you want to see growth patterns over the countries for the period of time that we have, now we can choose to plot only for the specific time. So I will add the if condition to filter. So if in list, then now in bracket, just use the country name because we want to work with the country name. So just in brackets, put the country name, and then after a comma, now start typing in the country that you want to use. If I want Armenia, you'll put it in quotes, and then the next one, say I want to work with Angola. And then for the next one, mine is still not displaying. You guys are lucky. Then the other one, I can have maybe, yeah, this one. So let's also add an overlay here and then hit enter. Let me try working with the do file because now it's like I'm getting even nothing in the results window. So just type that and see if you'll have something different.
I have some output.
For the countries that you specified.
Yes, it's three
Okay, that.
countries with the line graphs,
Mhm.
three different colors, and a legend that has an interpretation of the color and the country to represent. X-axis has the years and Y-axis has the GDP growth percentage annual.
Okay, that's perfect. So the reason why we used overlay is to have them in a. Do you have three different visuals or you have one?
I have one visual.
Okay, so now if you remove the overlay, I think you must get three different visuals. So try removing the overlay and then hit enter.
You know, if someone does not have the L
Mhm.
in their tongue, they might they might remove the ovary.
Wow.
But for for us, we are going to remove the overlay.
Overlay. Okay. So let me just close my starter and then open it again because I don't know why it's misbehaving. Let me save all these commands. Do you have different visuals after removing the overlay?
Yes, that is accurate. I have three different visuals.
Okay. Oh, I've not even used my data here, so let me start by copying my data. I don't know why this thing is misbehaving. After typing this, it should run everything. So let me just do it manually. Now let me try and see if it will run again. So, as we wait for mine, we can observe the general trends of how the three countries are fluctuating over time, how the GDP is fluctuating over time. So, I'm very sure you can say that there are some periods that we experience growth, and then there are some periods that we experience contraction, especially now that you are dealing with this data set, and we are talking about oh, wow. And we're talking about the GDP, the inflation, the unemployment rate, etc. Over the years from 2010 to 2025. We all know that from 2019, was it 2019 or 2020, we experienced Corona. So probably for the periods of 2020, 2019, 2021, there must be a contraction. I don't know if that's visible in your visuals.
Yeah, it is very clear.
Mhm.
And then it's surprising that there is one of these countries, AO, should be Angola. It has never gone back to the pre-COVID. Okay, it has not yet gone back from the data that's available.
Mhm.
It hasn't hit the pre-COVID levels of GDP. At least the other two have since recovered, and their economies look to be doing better than they were before COVID.
They have the fastest and strongest rebound.
Hmm.
But then for Angola, maybe they don't have structural diversification when it comes to reducing volatility. Because now, if the other ones have peaked and then they still are encountering the same, then that means they have a problem.
But then for Angola, you see that even before COVID,
Mhm.
COVID was just a perfect excuse. I think they hit a peak in maybe 2012, and they've been since falling. COVID was just a perfect slide, and they tried to rise up. But well, that's it. That's what I observed.
Mhm. So I don't know why mine is taking long, because now it's still loading.
I think you removed the ovary. Sorry, the overlay.
Instead of removing the overlay. So maybe you can practice also doing with a scatter plot. So for a scatter plot, um, we can directly type scatter, but then we have two types of scatter plots. So for a scatter plot, where should I type now? Let me see if the two file is working. So now we have the scatter plot. For scatter, you can just type scatter, and then now input your variables. Let's say if you're talking about the GDP growth annually, and then when it comes also to in terms of public debt, I hope I'm writing the right thing. Let me confirm. So you can just do a scatter. For scatter, we don't start necessarily with the xt scatter or whatever. Just type in the scatter. But then we have, so we are trying to look how debt versus the GDP growth relate. So we can have a look at the early potential relationships. And then the other option that we can use is the two-way. It has made the whole thing hang. Okay, now the other way we can use the two-way. It will give you the same results. Two-way, then in brackets, now you type in your scatter. The scatter. The scatter for the GDP annual and the debt. Wow, all that time. So for this one, it's only going to produce a scatter plot of GDP versus the public debt if you use if you only have the two, it's only going to give you a scatter plot. Comparing the two, you're not going to get extra plots or additional layers. But then, if you also include a scatter, you can have another bracket, maybe having another like variables. So you're going to get the first layer of a scatter plot, and then the second layer can have something like a line fit, a linear line fit, or a linear fit line. So you can use the scatter is used for quicker typing, and it's used when you want to work with a simple scatter. If you want to have combined or advanced graphs, you're going to go with a two-way, where I said you can add the, maybe you can just type these ones to show that it's on a new line, and then have other like variables here. Let me see if it's displaying. So I don't know what's happening with my starter, because now I'm seeing wonders. So after that, you can try performing the polled analysis. So we are going to work with the normal one. Let's say you want to perform a linear regression. Let me type here so that it will be easier for me to copy the variables. Let's say you want to work with regression, but then you want to work with something like the let me work with the GDP growth annual, and then let me also have a look at the inflation and maybe unemployment rate and public debt. So you want to work with those ones. You can just type in normally and then hit enter. You are going to get your observation. So the purpose of doing this is to get a simple baseline that ignores the panel nature. Remember, here we've not used the xt something. We've just used the normal one, normal baseline, to ignore the panel nature. But if we wanted to use one with a panel nature, okay, why am I repeating that? So if you want to do that, you will have to start with the xt, remember? So xt regression, but then we say that we have two models when it comes to panel nature, the two that are mostly used. So let's say you want to start with the fe, or the fixed effect. So for the fixed effect, after putting a comma, you'll just type fe, and then you'll be done, and then you'll hit enter. So the reason why we use for fe is to control for country specific time invariant factors. For example, the geographic or institutional characteristics. Then for interpretation, I say that you focus on the within country effects. And by this, let me give an example. If a country's debt increases by 1%, um, by 1% of GDP, then its GDP growth changes by beta values or beta units. So the FE controls for unobserved time invariant country specific characteristics. So for this, we can see that we have a model of, let's start from this point. We start by looking at the R squared values. So, for example, in this case, our R squared is 0. For the within is 0.0691. So that means that about 6.9% of the variation in GDP growth within countries over time is explained by the included variables. Remember, it's within, so that's why I said 6.91% of variation in GDP growth within countries over time is explained by the included variables, then about 17 for between, and then the overall is that we have the 6.4 or the 6.5%. Then after that you can look at the coefficients. Let me see if it has displayed first. So for coefficient, we can say that we have the coefficient of inflation. We can say that we have 0.0455. That means that a 1 percentage point increase on inflation is associated with the 4.5% point increase in GDP growth. But now we can see that the evidence is weak looking at the p-value. If you look at the p-value, we can see that the evidence is weak. Also, you can do that for all the unemployment. Just look at the coefficient and you work with the 1%. If you're working with a p-value of 0.05, then you're going to work with a 5% increase in unemployment is linked to this and this percentage point. If it's a negative, then it's going to be a decline. If it doesn't have a negative, then it's going to have something like it's going to lead to this percentage of increase in this specific variable. So looking at the implications, we can say that maybe unemployment rate, we can see that unemployment rate, interest rates, and debts consistently reduce the GDP. Let me look at inflation first. Then for inflation, yeah. So the finding is that for unemployment rates, the interest rates and debts negatively affect the growth, looking at how the values are ranging. And now you can do the same for the RE. For the RE, so instead of typing, let me just change this one to RE. So we use RE when both within and between country variation. I wish I could have used a smaller data set also for you to be able to understand easily. But for RE, we use it when we want to work with both within and between country variation. So assuming country effects are random and uncorrelated with predictors. So for the model results, you also focus on the R squared. The R squared is going to give you we have an R squared of 0.06. Let me confirm with the pooled one. Yeah, for the pooled one, we also had 0.06. So the overall, unlike this one, for the FE, it was a bit different. So we can say that for the overall r squared value for RE and the pooled one. So the pooled one is this one that doesn't have the FE. This one just works with it normally without having to include the panel data here. So we can see they have very similar values. So now there is another thing when it comes to comparing the models. When you want to choose the preferred models, you can just work with both, and then you there's a command called Husman where you use it to select between the two which one is going to work. So you can choose Husman FE and RA. Just type Husman FE and RA. But sometimes it doesn't work because we've not saved our results. So now we'll go back to this. We'll have to rerun our models and store the results. So for example, we'll start with this one. Which one? Let me start with the FE. So after typing the FE, on the next line, just save. And to save or to store the results, you will type in something like so don't save like literally saving, because now you'll be saving the whole data set. So just use estimates, then store the F model. Then on a new line, so you can control enter. I don't know if this one will be lost, so let me just copy it first. On a new line, type the one for RE, and then also save it using the estimates. I hope that's clear. You just use the same command that we used to run them. And then now use the estimates. So if it's an RE model, rename it as something like RE model. If it's an FE, save FE model, then hit enter. And now that means that your results are stored. So now to run a Hussman test, we are not going to use the FE and the RE that we used before, because now we've renamed to RE model and FE model. So I just type FE underscore model, then RE underscore model. Now hit enter. So here,
Virginia, sorry,
yes,
quick one. I don't know what I did to my starter because I'm getting a very. See how you're able to read the data very clearly
yeah,
on your end.
uh-huh.
Mine is just, I don't know. It's just Matagoga news.
What is it showing? Is it the one like I was getting also for my graph? Because for my graph, I've not yet understood what happened.
Well, this one, I think I got the same because we were
Oh,
now
you get the
looking
same?
at the, yeah, for all 200 and something countries.
Uh-huh.
So it was coming like this. But for other commands,
It worked. Though it's not
yeah,
supposed to come like this. So I don't know. There must be an issue. We can redo that. Because now for Anthony, it works.
the
This,
others
we can't
others,
even call this one a graph.
I don't know. Can you allow me to share my screen for just a bit
Yeah,
so that you
okay. It's
see
okay.
what I'm seeing?
It's okay.
Mhm. So this is how I'm getting my output. What am I doing wrong, or what did I touch?
Just a minute. Did you specify all the annual inflation and employment?
So I stopped here because now I started getting funny stuff, and I decided to just follow your screen.
Mhm.
I tried again, it brought the same. So I don't know why does it look like this? Like it's not, the table is not very clearly outlined
Okay.
as opposed to
So
what I was seeing on your screen.
for that, I don't know. Did you copy all the values
Uh,
the table? Because now I wonder why our Stata is behaving that way. So maybe what I can tell you, we
mm,
can import. Anthony, did you import the file or you copied?
I imported the file.
Okay, maybe that's the reason. Because I think there's some things that we are missing, Winnie. So
mm,
we can all start with the importation.
okay,
We'll import it, then now we can work on it. Because I'm also having missing values. There are
okay.
some things that are missing. For example, for the graph, yeah, there must be a
So,
problem. So we will work with the importing method. Let me just finish illustrating this, then we can do the importation.
sure thing. Okay.
So I said use the Husman, but now remember how we have saved our models. We used the estimate, then store if it's an RE model or FE model. So if you're running a Husman test, ensure that you use the names that you used above, Husman FE model and then RE model. So now we're going to focus on the probability greater than chi-square. If it's greater than, if it's less than 0.05, in this case, for example, we have 0.003, then we can say that fixed effect is preferred. So we are going to work with the results of the fixed effect and we're going to ignore the RE. But if the probability greater than chi-square is greater than or equal to 0.05, then that means that random effect is fine. Because remember we say that we are using those models to check for heterogeneity by assuming the unobserved country effects if they are uncorrelated or correlated with other measures. So if we have less than 0.05, I said you are going to work with the FA. But because, okay, in our case, you're going to work with the FA. But if we have greater than 0.05, greater than or equal to, then we are going to work with the RE. Then here, what else can I talk about when it comes to here? We have the so the null hypothesis of the Husman is that random effect is consistent and efficient, meaning that there is no correlation between unobserved country effects and regressors. But then the alternative, let me repeat that, for null or the HO, uh, assumes that our RE or random effects is consistent and efficient. And by that, I mean that we have no correlation between unobserved country effects and regressors. But if we have an alternative or H1, then that means that RE is inconsistent. So meaning that there is correlation. So now there you will have to use the fixed effect. So we have the chi-square of we have the chi-square of 18.80, and then the probability is greater than chi-square. We have 0.003. So our decision in this case is that we are going to reject the null hypothesis. We are going to reject the null hypothesis, and then we are going to our conclusion is that we are going to work with the fixed effects because our unobserved country-specific factors are correlated with the independent variables that we have. So for the dependent variables, in this case, we were talking about, let me just do that again. Remember, this is our dependent variable. Remember, when we're talking about regression, we say that the first one is a dependent, and these other ones are the independent ones. So in this case, we can say that our factors are correlated with the independent variables. So we are going to use the fixed effects, or the fixed effects results are more reliable in our dataset. So when I say that we are going to use the FE coefficients or the results, I am trying to say that we are going to, let me rerun that again. I'm saying that we are going to look at unemployment rates, real interest rates, and public debt as factors that are significantly reducing the GDP growth. So inflation, for inflation, we can say for unemployment rate and then public debt, we can say that it's negative. They are not statistically, this one is not statistically significant. So when we are working with the random effects, then that means that it will have underestimated these effects, especially when it comes to unemployment and then the public debt. So I think I will redo that tomorrow also because of the dataset misbehaving. Winnie, so ensure tomorrow you also import. Use the option to import. Let me show you that. Now go to the one. This one file, then import. This is a CSV, and then now you're going to browse and select in your local file location.
Okay.
So we will redo that tomorrow before we look at the same in SPSS. Any question at that point?
I have no question up to that point.
It's okay. So I'll see you guys tomorrow. I'll make sure that I'll redo the same because I know it might be difficult, especially to understand the in between. We have the in between and the in between and the within. What am I saying?
I get you.
I think I must be the within and the between. These ones, it might be difficult, so I will do that again tomorrow just to explain how to interpret these.
Yes, please.
It's okay.
You said in within?
No, in between.
No, I'm being silly.
Within and in between.
Wow, it's supposed to be.
Within and between.
Yeah,
We
I was
understand.
confused. It's
It's
okay.
okay. It's okay.
Thank you
Awesome.
guys. I'll see you tomorrow.
Please share this recording.
I will.
Don't forget.
I'm going to upload it. Yesterday I wanted to upload, but then I realized that it was not displaying anything on the screen. It was just a wallpaper, showing a wallpaper.
You're on mute.
Oh, wow.
I need
Hey,
to make
today
sure
is the
Gracie
day.
is
So I say,
Oh, yeah.
I said that
Yes.
yesterday I realized that I was yes, I was recording the class, but then it was just displaying a wallpaper. It didn't have any like important information. That's why I didn't upload that.
No. Oh, okay.
And now you're going to recap it because
You
the
had
last
challenges. So if I will recap. Now I'll have to do a recap.
Okay.
With Winnie and betweenie. Eh, within and
With
between.
me,
Sorry.
mi najitetea mimi
Acha class
myself and
rep
I.
ajiongee.
No, Winnie, I'll be there. I was
But
just saying.
when I speak, I'm speaking for the rest of
So,
the
so,
class.
so
Yes,
remind me.
definitely.
Yesterday we looked at predictive models and
Mm,
associations, right? Together with the t-tests.
That's,
mhm.
Okay, yeah, it's all right.
You lost me after scatter, so yeah.
scattered you.
W
And you
no
speak
correlation,
It scattered her
correlation.
into
EW,
pieces.
EW core. And then I was gone.
scattered you. Eh?
Please, ninajitetea upande wangu.
No. For the class, please.
Okay.
It's all
So
right. So I'll do that. Then I'll make sure I upload also.
on Thursday,
Yeah.
tomorrow,
So
tomorrow we
tomorrow
do
is
this
a
on Thursday.
Wednesday. So tomorrow we are
Thursday.
going to redo this, but then
Yes.
Thursday,
Mm.
on Thursday, okay, tomorrow we can do this. Then we also look at SPSS, but on Thursday we'll do a recap. So for tomorrow, maybe I can give you questions concerning the same, so that we do it as a discussion. But that's not the main project that I'm going to give you. As much as you
Okay.
said I should not give you a lot of work, I had your complaints, but still, you must work on something.
It's important
Yeah,
for understanding.
yeah.
Yes.
It's all
So
right. Have a
thank
good night.
you. You
You
too.
have a good
Bye
one
bye.
too.
See you tomorrow.
Okay.
Winnie, you also have a good night.
You too. See you tomorrow.
So,